Okay, today we don't really have a number for this lesson. I guess it's sort of considered part of either Chapter 5 or Chapter 12. We're moving from Chapter 5 to Chapter 12. There is some overlap, but we are going to graph quadratics, which graphing quadratic equations means we're graphing parabolas. Does anybody know what shape a parabola has? You're kind of right. There are two sides to it. So a parabola looks like a U. So if you want to make a little U graph next to it, they open up like a U. Sometimes they open up, sometimes they open down, but parabolas look in general like U's. Jumping right into the notes. A quadratic equation is of the form y equals ax squared plus bx plus c, which that should look familiar. What we've been factoring, a lot of it looked like the ax squared plus bx plus c part of it. But now we're turning it into an equation or a function that also has a y associated with it. The graph of a quadratic is called a parabola, as we talked about on that first slide. A parabola can open up or down. When the leading coefficient a is positive, it opens up and has a minimum value. When the leading coefficient, so when they say that a is negative, it opens down and has a maximum value. So we should be somewhat familiar with looking at a to see if it's 1 or if it's not 1 when we were factoring. On these, deciding if our parabola opens up or down, we're looking to see if that number is either positive or negative. Positive, it opens up, so it looks like a right side up U. Negative, it would be upside down. Upside down U, kind of like an arch. The solutions of a graphed quadratic are the x-intercepts. They are also called the zeros. To graph a quadratic, make a table of values and plot the points. So when they say a table of values, they're talking about an XY table where we pick what goes in for X and then we figure out what Y would have to be if we plug in that X. I also want to revisit the idea of an x-intercept. So an x-intercept is the point where the graph touches the x-axis. So I'm just going to make a note of that. That's where the graph touches the x-axis, which is the one that goes side to side. X-axis is side to side, y-axis is up and down. Even draw yourself a little picture of that. That's our x-axis. So if we were to have a parabola in it, our x-intercepts are where it touches that x-axis. All right, so at the top here, above our graph, it says opens blank, so blank value. So what that means is we need to determine if it's going to open up or down. And based on if it's opening up or down, it will either have a minimum or maximum value. Now to decide if it opens up or down, we need to know if A is positive or negative. So remember our general form is y equals ax squared plus bx plus c. So a is right out in front of the x squared. What's out in front of my x squared on this problem? Some people said it. A 1. So is a positive or negative? A is positive, so this graph is going to open up or down? Up. So when your graph opens up, that looks like a normal U. Does anybody remember from our notes or look back to your notes? Is it going to have a minimum or a maximum value? A minimum, and we can see that it's got a lowest point on it. There is a minimum value. All right, we've got a minimum value. We'll write what that minimum value is as an ordered pair in just a minute. So on your note page, you can see that it left you a space to write in what that minimum is. We'll figure that out in just a minute. All right, before we figure that out, we are going to make our XY table. So you can see they've already set up a table for us. We get to pick what goes in for X, and then we find what comes out for Y. So somebody tell me something they want to plug in. Could be anything within reason. We want it to fit on our graph. What do we want to plug in for X? 4 is not going to fit on our graph. 2 should. So this graph is pretty small, so we got to pick somewhat small numbers. 2 should fit. So if we plug 2 in for X, that's going to be 2 squared in this case. So the 2 gets squared. What is 2 squared? 4. So our ordered pair would be 2, 4. That's the point that I would graph. So this middle column is just kind of where we show our work. Who can tell me how to get to the point 2, 4? Jaquan? Over 2 which way, left or right? Good, 2 to the right, then up 4, and we put a point. Okay, I need something else to plug in for X. Keon, what do you want to plug in? 5 is going to be too big. Deja, what do you want to plug in? -2. I think that's a good idea. We need to plug in both positives and negatives. We have to be careful when we plug in negatives that are getting squared, that we put that number inside of parentheses to square it. If we square a -2, what do we get? A +4. Remember, a negative times a negative equals a positive. So a negative number getting squared comes out positive. So we've got the point -2, 4. How am I going to get to that point? Keon? Left 2, up 4. Good. Put a point there. Now, this is making it look like my line might be a straight line. That is not the case. We got to plug in more points to get a good idea of what this graph looks like. So I got to have something else to plug in. Jaquan? 3 is going to be too big. Natalie? 1 would work. On these, I would generally stick with pretty small numbers. Now, let me just show you real quick why 3 is not a great idea for us. If we take 3 and square it, what do we get? No. 9. 3 times 3 is 9. Is the point 3, 9 going to fit on this graph? No. So that's why I keep telling you some of these things are too big. 1, however, is not too big. If we take 1 and square it, what do we get? A 1. 1 times 1 is 1. Are we okay with 1 squared being 1? Okay, how do I get to the point 1, 1? Right 1, up 1. Okay, so this is giving me a better idea of what this graph is going to look like. We still have not plugged in the easiest number to plug in ever. 0. That's where I would usually start. What's 0 squared? 0. So 0, 0 is another point that I want on my graph. That's also the easiest point to graph. It's at the origin. Alright, I want to go ahead and plug in one more point just so that we get a good idea of the symmetry of this. Jaquan? -1. Just so that we get a really good idea of what this looks like or how this graph behaves. What's -1 squared? +1. So -1 comma +1, how do I get there? Left 1, up 1. All right, so now we get a good idea about our U shape here. Remember when we graphed lines, I was very picky that you had to have really straight lines, that you needed to use a straight edge to make them. On these, they shouldn't be straight. This should not look like a V. It should be curved, which means that it might not always be pretty, and that's okay. All right, it should look like a U. It should be curved. Absolute value graphs make V's, and that's not what this is, so it shouldn't look like a V. Now, it might take you a couple tries to kind of get a good feel for it, so I maybe wouldn't mark it in really dark until you're happy with it. Also, the edges of it should not point straight up from this point. So what I mean by that is when you hit this point here, it should not follow the grid line and go straight up. It should still be curving outward just a little bit. Okay, so again, my line's not perfect. I don't have a steady hand to get a perfect curve in there, but it's pretty close. Looks like a U, not a V. Lines aren't pointing straight up. All right, so let's go back to that minimum value. What's the lowest point on our graph? 0, 0. It's pretty easy to identify on this one. All right, on the back, example 2, we've got y equals -x squared plus 2. So again, on your paper, we've got the opens part. Which way is this going to open? Down. Why? Good. In front of our x squared, we've got a negative, which means it's a -1. So this one's going to open down, which means it's going to have what kind of value? A maximum. If it opens down, then there should be a highest point on it that we call the maximum point. All right, we'll figure out what that is while we graph it. So, if last time was any indication, we should have a good idea about what numbers we might want to plug in. What do you want to start with? 0. 0 is always a great number to start with just because it's usually pretty easy. Now remember, only the x is getting squared, which on this one doesn't make it too difficult, but what is 0 squared? 0. The opposite of 0 is still 0. Plus 2 is 2. So we got a point at 0, 2. We'll go ahead and graph that. How do I get to 0, 2? Straight up 2. So 0 for the first number means I don't go left or right. I'm just going straight up 2. I'm going to switch colors on this one. Okay. Next point we want to plug in for x. Natalie? 1. is a great option. Remember, only the 1 is getting squared. So what's 1 squared? 1. Then we take the opposite of it, -1, and then we add 2. So -1 plus 2? 1. Some people were saying it, some people seem confused. So that point is going to be 1, 1. Do we have questions about how we got it? Okay. 1, 1 we graphed last time. We go right 1 up 1, put a point. What do we want to do next? Jamal? -1 sounds like a good idea to me. Okay, what is -1 squared? 1, the opposite of 1 is -1, and then we add 2. We get a 1 again. So now we've got -1, 1. Again, we plotted that last time. It's right there. Left 1, then up 1. So we are getting a pretty good idea of what this looks like, but let's go ahead and get 2 more points on there. What do we want to plug in next? 2 is a good idea. What's 2 squared? 2 squared? 4. Okay, the opposite of 4 is -4. -4 plus 2 is -2. So we have the point 2, -2. To get to 2, -2, I'm going to go which directions? Right 2 and then down 2. Now, if you had to guess, where do you think our last point is? -2, comma. -2, comma, -2, right? We can kind of see that these points kind of pair up. And so if we plug in a -2, again, -2 squared is 4. The opposite of it is -4. Then we add 2. We get -2. So we can see that other than our minimum or maximum value, our points pair up. We'll give more detail to what that means later, but our graphs should be symmetric. All right, then we just have to graph our line. If you put all the points but then never draw me a line, you're going to lose points. We need to have the line. It should curve like a U. Doesn't have to be perfect. It should be pretty big through our graph. Obviously, it's not going to the top because it opens down. So our last thing we need to do is identify that point that's at the top of our graph. What point is that? 0, 2. That's our maximum. All right, on number 3, we'll talk about our opens up, down real quick. And then I want you to start filling in the table on your own before we go through it together. So, which way is this one going to open? Good, it opens up. Our leading coefficient is a positive 1. So it opens up, which means it's going to have what kind of value? A minimum value. Now, let the first 2 examples guide you when you go to make your XY table. These graphs are pretty small, so you'll want to keep reusing a lot of the same values we've been using for X. That way we can be sure that they'll fit on our graph. All right, we already talked about this one. Opens up, has a minimum. I'll add that back up there. Let's grab our handy dandy popsicle sticks, since I keep hearing from the same handful of people. Houston, what's something you plugged in for x? 0, I like that one. And what did you get for y when you plugged in 0? Good, -3. I like that. So where do we graph 0, -3? Anybody? Down 3. So we start at the origin, go down 3. There it is. All right, next up. Ryan, what'd you plug in for x? 1. And what'd you get out for y?
1.
I disagree. What is 1 squared? 1. 1 minus 3? -2. Good. So 1 comma -2 is going to be another point. Are we okay with the -2 on that one? Okay, so 1 -2, I go right 1 down 2. Jamal Dixon, what'd you plug in for x?
2.
Sure, 2. And what'd you get out for y? 1. Good. 2, 1. So 2 squared is 4. 4 minus 3 is 1. To get to that point, we go which directions? Right 2, up 1. All right. Then we need a couple points on the other side, which should make our lives a little bit easier. Deja, what did you plug in next? Good. -1. And hopefully we know, even without plugging it in, what we would get. What'd you get out, Deja, for y? Good. So -1 comma -2. So that's the mirrored image of that other point we put at 1 comma -2. So we've also got one at -1, -2. The last number that we should have plugged in on this one, Jamarl. 3. Oh, I think 3 probably would fit on this graph. Do we want to do 3? We can try 3, sure. What's 3 squared? 3 squared is 9. Minus 3 is 6. So somebody was just jumping ahead. 3 comma 6. So this one will just barely fit on our graph. We'd go right 3 and then up to the very top of our graph at 6. So it does fit on our graph this time. Kelby, what else could we plug in? -2, and when we plug in -2, what do we get out? 3. -2. So if we take -2 and square it, what do we get? 4. 4 minus 3 is 1. So we would have -2 comma 1. Okay, again, it should be a mirror image of this point over here. And if you really wanted to get your last mirror image, which I'm not requiring, we've got enough points, but we would also have a point at -3 comma 6. We want to fill in that last one. Now, you don't have to have all of these points, but the more points you have, the more helpful it is. We definitely need to know our minimum point. What is our minimum point? 0, -3. And then we need points on either side of that to be able to get our U shape. So you don't necessarily need every single one of those points, but you should have at least 2 points on either side of your minimum. So a total of 5 points are required. We ended up with 7 points on here. That's fine. We just did a little extra. Okay, so if you want to write that off to the side somewhere, like 5 points required for these graphs, that might be useful. Ready for the next one? All right. This one is written just a little bit differently. On this problem, we have to decide what our A is, but in order to decide that, it might help us to rearrange it. If I want the x squared to go in the front, what sign has to stay with it? The negative or the minus sign? So that negative sign's got to stay with the x squared. So I could rewrite this as a negative x squared, and then what sign goes with the 4? A plus. The 4 was positive, so we could put plus 4. Now that we've got it rearranged, which way is this one going to open? It's going to open down. So is it going to have a minimum or a maximum? Maximum. It will have a highest point. Now, my go-to numbers to plug in for x would be everything between -2 and +2. That will change sometimes. We might be able to plug in other numbers. But when I set these up, I like to just right away write out all my x values that I'm going to plug in. If you want to keep doing them one at a time, you can. This is just how I like to do them. This is how you'll usually see them set up inside textbooks, smallest to biggest. All right. When we plug in a -2, -2 squared is 4. The opposite of 4 is -4, and then we add 4 to that. 0. So -2, 0 is one of our points. How do we get there? Yes, on the graph. How do we get there? Keon? Where? Not down to. Not up to. Over which way? To the left. We want the -2 that's on the x-axis. Let's plug in our -1. What is -1 squared? No. +1. Then we make it negative because of the negative sign out in front. So -1 plus 4 is 3. So we've got a point at -1, 3. How do I get to that point? Jamal? Left 1 up 3. If we don't remember how to graph our points, then it's not going to help us at all if we can find the points if we can't plot them. We've got to remember our directions for our XY coordinates. Next is my favorite number to plug in. 0 squared is 0. The opposite of 0 is still 0. 0 plus 4 is 4. So we have a point at 0, 4. How do I get there? Up 4. So the first 0 means I don't go left or right. That 4 means I just go straight up 4 on the y-axis. Again, the y is what was 4. Y is 4. So on my y-axis, I went to 4. Now, if you've been catching on to the patterns of how these graphs work, the next 2 points, you probably could already guess where they go on your graph. but we'll go ahead and find them by plugging in. What is 1 squared? One, the opposite of 1? Negative 1 plus 4 is 3. So we've got a point at 1, 3. How do I get there on my graph? Right 1 up 3. Last but not least, we're going to plug in a positive 2. 2 squared is 4. The opposite of 4 is negative 4. Negative 4 plus 4 is 0. So we have a point at 2, 0. We need to get the shape of our U, so we need points on both sides of our maximum point. So to get to the point 2, 0, where do I go? Right 2. Now we probably could fit more points on here, but we've got 5 points, including our maximum value, so we can go ahead and just graph. If you wanted to plug in 3 and negative 3, they probably would fit on your graph just fine, but we don't have to put them on there. So our last thing to decide is, where is that maximum point? 0, 4. Good.